Hi, this is Swapnil Bhartia and welcome to another episode of TFR Insight. And today we have with us Haim Helman, CTO of Octarine. Haim, it's good to see you again after such a long time. Last time we saw each other was in KubeCon, if I'm not wrong.
Yeah, that's true. So it's really good to be here.
So today we are going to talk about your recent blog post that you made about a sidecar and how it might appear in Kubernetes 19. But before we get into all of that, I want to understand what are sidecars and what are they used for?
So Sidecar is a design pattern that was introduced by Google. And the idea is that an application can offload a lot of its network functionality to a different process that's going to run in a container sharing the network namespace of the application. And that process can handle things like retries, traffic shaping, load balancing, authentication, encryption. So there are a lot of common functionalities that all applications need. And the idea here is to offload both the configuration and the implementation of all those functionalities from each individual application to a common process that's implemented once and then runs alongside each container. In Kubernetes, that means that these are two containers running in the same pod, which means they are sharing certain aspects like the network namespace, but are separate on other aspects as well.
But this concept is not new to Kubernetes, so why are we talking about it now? What kind of need has changed?
So from a very early stage, when sidecars were introduced, a few very basic problems arose that had to do with the life cycle of the pod. So we have our application container, and then we have our sidecar container, and they both are started independently, and they both go down independently when the pod is shut down. And these problems remained unanswered for a very long time, even though they had significant implications for the most common use of sidecars, which is the service mesh. So in Kubernetes, there are multiple implementations of service meshes such as Istio, Linkerd. All of them are using sidecars, and all of them face the same challenges regarding the managing of lifecycle of containers in the pod. A few examples. When we have the application starting up, in many cases, it is trying to create an outbound connection. In the sidecar architecture or pattern, this communication has to go through the sidecar container. However, if the sidecar container is not up and running, that initial communication will fail. And if the application itself did not have a way to handle retries or to recover from such an error, then the application itself will fail. Another example is what happens at shutdown. So, for example, Kubernetes is meant to run jobs. Jobs are not long-running processes. They are short tasks, and they have a beginning and an end. And the way to identify that a job has ended is that the container that ran the job has exited. The problem is that if you have a sidecar running, the pod is still running a container, even if the application container has shut down, and therefore the pod will not shut down and the job will not end. A third example is the case where the application has to do some network communication when it shuts down. So if for some reason the sidecar shuts down before the application itself, the application will experience errors as it is trying to shut down.
Look at Sidecar, as new features are being added. How does it actually affect the overall behavior of sidecars? Can you talk about that a bit?
The idea here with this introduction of the sidecar container as a first-class citizen in Kubernetes, the idea is to designate containers as sidecars, which means that in the life cycle of a container, the sidecar container will be started first, and then only when it is ready, the application container will start. And then during shutdown, the shutdown of the sidecar will happen automatically and only after the application container has completed going down.
What kind of effect sidecars have on service mesh?
So currently there are a lot of cases where service meshes cannot cover certain applications, or they require some change in the application code to run in order to overcome the lifecycle issues that I've described before. So some applications, again, don't handle errors on startup correctly. We have jobs that run and end. So for example, now in most service meshes, jobs cannot be instrumented. So that limits the coverage of the service mesh along with its functionality of collecting telemetry and performing traffic shaping. So it cannot cover a pretty significant part of the applications that users are deploying today into Kubernetes.
What is the importance of sidecar for security of workloads in Kubernetes?
For security, the base thing you want to do is to create a zero trust environment, which is something that service meshes do very well. So they provide encryption and authentication based on mutual TLS. In addition, service meshes are used to collect telemetry that can be used to detect anomalies in service behaviors. They enforce access control policy that can be used to segment workloads that have different security requirements. And again, in security, coverage is everything. Being able to monitor and enforce policy on 80% of your workload is simply not enough. So we strive to always reach 100% coverage. And what happened today is that for workloads that could not use a sidecar, we had to find workarounds, or we just did not have that necessary coverage. So the idea of the sidecar life cycle, which eventually will lead to much better coverage of workloads by service meshes, as well as maybe allow companies to implement service meshes where they did not do that before because of those limitations, will increase significantly our ability to provide complete security for those environments.
How would you define zero trust security?
So zero trust security or zero trust networking means that all communication between devices, between applications is first of all encrypted and then authenticated. So we do not rely on a certain network zone or network identity in order to identify who is the initiator or who is the server of communication, but we verify everything. So mutual TLS is a great way to achieve both encryption and authentication of both sides of the communication. and that will span across networks, whether it's within the corporate network, whether it's crossing zones, regions, or covering the public internet as well.
If you look at the current situation right now with COVID-19, a lot of things, the way we work is changing. The good news is a lot of people in the open source community, they already work from home. I work from home, but there will be some layoffs. People will be let go of. And if you look at open source world, Linux Foundation comes out with a report every year. There is a big, huge, kind of demand and shortage of talent pool. What kind of impact it will have, especially on the security space? And how do you plan to turn this lemon into lemonade?
So we already see with our customers that everybody's trying to do more with less. And that's a combination of both the skill shortage that exists in the cloud native space and in the security space, but also because of financial restrictions of companies, and they're trying to limit their spend. What that means for security is a lot of automation and kind of introducing methods from the DevOps space where everything, where one or two people can manage pretty large infrastructure deployments and large environments into the security space. So being able to automate processes like risk management in Kubernetes, threat detection, remediation, all those are becoming more critical as companies try to control the number of people they have engaging in those activities.
Haim, thank you so much for taking your time out and talking about Sidecars, and I look forward to talking to you again. Thank you.
Thank you very much, Bob. Thank you very much, Bob.